bucka. Haha. You know the deal.
The next thing we're going to talk about in analytic geometry is what's called the point of intersection. And in order to do that, we're going to explore a couple of real-life examples here of linear relations. So the first example here is where we've got a banquet hall that we're renting. And the first banquet hall charges an initial fee of $200 and then $5 per person. So we've talked about these types of equations a few times. And by now, writing the equation should come pretty quickly. We know that our initial fee is $200, so that's our y-intercept. And our rate of change here is 5, because for every one person, it costs $5. So our equation for this situation is y equals 5x plus 200, where x is the number of people and y is the total cost for the banquet hall. For the second banquet hall that we have here, the second banquet hall just charges $25 per person, so there is no initial fee. So again, when we want to write the equation for that, our rate of change is $25, and our y-intercept is 0 because there is no initial fee here. So our rate of change is 25 because for every one person, it costs $25. So our equation is y equals 25x. Where x again is the number of people and y is the total cost. So here I've gone ahead and I've graphed each one of those equations here. So the first one that we had where the banquet hall charged $5 per person and the initial fee of $200, that's our green line there. And the arrow here indicates that it does go on forever. And our banquet hall that charged just $25 per person, that's our black line here, and there's our equation for that. And again, it does go on forever. So you'll notice here a couple of things. First of all, the green line is a partial variation, because if 0 people go to this banquet hall, it's still going to cost $200. So we do have that initial fee of $200. Whereas the black line is a direct variation. If 0 people go to the banquet hall, it's going to cost us $0. Another thing you'll notice here is that the two lines do meet, and they meet at this point here. That is our point of intersection. So the point of intersection, again, is where two lines meet. And the coordinate there, if we look at that point, our x value there is 10, and our y value there is 250, because our y values are counting by 50s here. So what does this mean for this example? Well, if you recall, x represented the number of people. So in this case, x is 10, which means our point of intersection here happens when we have 10 people going to the banquet hall. And when we have 10 people going to the banquet hall, the cost is $250. And the cost is the same for each one. So for the green line, if we substituted in 10 for x, well, 5 times 10 is 50, and 50 plus 200 is 250. So the y value that we would get there would be 250. If we substituted x to be 10 into this equation, 25 times 10 is 250. So again, we get the same value for y given this value for x. And that's the only time that happens for these two lines, because these two lines only intersect at one point, and the coordinate that they intersect at is 10 and 250. And again, what that means for this example is, well, if we're deciding which banquet hall to rent, if we're going to have 10 people go to this banquet hall, it doesn't really matter which one we rent, because it'll be the same cost. The cost will be $250. If less than 10 people are going to go to the banquet hall, well, that means we want to pick the black line, because the black line is cheaper. It's below the green line, so that means that the cost is less when the amount of people is less than 10 people. If it's more than 10 people, we want to choose the green line. We want to choose this banquet hall because the cost will be less for more than 10 people. So for example, let's say we had 20 people that were going to go to this banquet hall. Well, for the green line, that's our coordinate there. 5 times 20 is 100, plus 200 is 300. So the cost for 20 people for banquet hall A is $300. But for the second banquet hall, that's our coordinate for 20 people. So if we substitute in x to be 20, 25 times 20 is 500. So for that banquet hall, if 20 people go, it's going to cost us $500. So in this case, it makes more sense to choose the green line, the first banquet hall that had that initial fee of $200, but then only $5 per person, because it's cheaper. And again, it's anytime we have more than 10 people, the green line is going to be cheaper. But if we're not going to have very many people go to this banquet hall, if we're going to have less than 10 people go, we want to choose our black line, our second option, where they're charging $25 per person. But again, the point of intersection here is where the two lines meet. And where the two lines meet is at the coordinate 10, 250. And for this example, the cost is the same at that coordinate. So let's look at two more examples of just now equations of lines where we have to find the point of intersection. Now for our purposes in grade 9, in order to find the point of intersection, we're only going to do it in one way, and that's by graphing. When you get into grade 10, you're going to find that there's a couple of different ways that you can find the point of intersection. But for grade 9, we just do it by drawing the graph and looking to see what the coordinate is where the two lines meet. So in the previous two videos, we talked about a couple of different ways to graph lines. So I'm not going to talk about that again, but what we have to do here is we have to graph each one of these equations. So I'm going to go ahead and do that now and graph 3x plus 2. So there's our graph for 3x plus 2. Has a y-intercept of 2 and a slope of 3. And then I'm going to go ahead and graph 9x minus 4. So there's our graph for y equals 9x minus 4. And if we look at these two graphs here, we can see that the coordinate where they intersect is there. And what is the coordinate there? Well, our x value there is 1, and our y value is 5. Now let's talk a little bit about why that's the point of intersection. If we substitute these values into either equation, so if we put it into the green equation, say, our y value is 5, and our x value is 1. And now if we solve that, 3 times 1 is 3, and 3 plus 2 is 5. So what we get is a statement that says 5 equals 5, which is a true statement. So that means that this coordinate is on that green line. If we do the same thing for the black line, with the black equation there, we get 5 equals 9 times 1 minus 4. 9 times 1 is 9. Minus 4 is 5. So again, we get the statement 5 equals 5, which is a true statement. So that means that this coordinate is also on the black line because it works in the black equation. This is the only coordinate that will work for both because it's the only coordinate that's on both lines. So another example, if we, let's say, took this coordinate here. So that's at 2, 8. Well, if I substitute that into my green equation here, we get 8 equals 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. So we get the statement that says 8 equals 8, which is a true statement. But if we try to substitute that coordinate 2, 8 into the equation y equals 9x, we get 8 equals 9 times 2 minus 4. Well, 9 times 2 is 18, and 18 minus 4 is 14. So we get a statement that says 8 equals 14. Well, that's not a true statement. 8 does not equal 14, which means that this coordinate cannot be on this line. And we can see it's not on the line. That coordinate is not on the black line, and we can prove that it's not on the black line because when we substitute it into the equation doesn't work. It doesn't make sense. But when we substitute it into the green equation, it does make sense. And again, the coordinate 1, 5 is the only coordinate that will work for both, as it did here and here. So once again, when we're trying to find the point of intersection in grade 9, the only way we can do it is by graphing. So we have to graph each of the lines and then look to see where the two lines meet. So to finish off our lesson on point of intersection, what I'm going to ask you to do is for each pair of equations here, what you're going to have to do is graph each equation and state what the point of intersection is. So for example, with question number 1, you've got the two equations there, y equals x plus 3 and y equals 2x plus 8. So for each one of those equations, graph them, draw them on a graph, and state what the point of intersection is. It's up to you how you want to graph them, what method you want to use. You'll notice question number 3, those are not written in slope y-intercept form, so you might want to put them in slope y-intercept form first. And then again, just state what, if any, point of intersection there is. If you're able to do that, congratulations, you now have a firm understanding of point of intersection of two linear equations.